Hi everyone, my name is Jared. I'm going to talk about our work on SkillSleeves, designing electrode garments for wearability. This is work I did with my co-authors, Rachel, Marion and Paul. And recently we've all been doing a fair amount of work on the design of e-textile wearables, e-textile sensors, and also building garments for electric muscle stimulation. And in this paper we kind of bring together all the knowledge we've got from those various design processes and reflect on what we've learned about criteria for wearability. So in this talk, I'm going to talk about our work on electric muscle stimulation, which kind of grounds everything we present about wearability, and Paul will make those presentations about wearability. So EMS has kind of emerged as quite a popular new interaction modality, and so our interest has always been in how we can try and make the resolution of EMS a bit finer, such that we can get to the point where maybe we can do fine-grained finger control and teach people to play the piano, or smoother arm control for teaching people to play tennis and things like that. And for this reason, we very quickly turned our attention to wearable electrode sleeves as a good means of kind of being able to just put on sleeves and then go and do whatever activity you're going to in the future.
So what really fascinates me about this idea is it highlights the potential of garments connecting with bodies in even more intimate ways than our current clothing does. So our clothing already provides us with this protective layer that in many ways augments our abilities. But in this vision that Jared kind of laid out, clothing becomes something more of an extra organ or even a collaborator in our day-to-day activities. And we've seen these kind of ideas in art and fiction. A well-known example is the space jockey from Alien, which is this creature linked to this control station through their clothing. A less menacing example are maybe the still suits in Dune, which act as a second skin and allow the wearer to preserve and recycle humidity so that they can survive in really dry environments. This suit here actually was made by our friend and collaborator, Rachel. So in the literature, wearability is usually discussed within super specific framings. We have technological framings where questions are like, can the antenna work if it's placed under the arm or is it shielded? And then on the opposite end of the spectrum, we have questions regarding, what does the aesthetic of this wearable actually express? Or is this wearable something that's socially acceptable? Can you go out in public with this? And then there's another way of framing it around sensory motor processes, which I really like. One of them being a biomechanical framing where you discuss wearability as something which can't inhibit your range of motion, and as soon as it does, it's not wearable. Or a psychophysical framing. And here the idea is kind of that the objects in your environment, they draw your attention. But once something stops drawing your attention and recedes from your attention, much like our clothing does, and the moment where it kind of vanishes, it becomes wearable. When we set out, we had this vision of, applying hundreds of electrodes to a sleeve. And we realized that in the way wearability is being discussed, something is missing, and that's the question of deployability. Something that we really cared about is we wanted to be able to run an experiment. So we needed to be able to apply these hundreds of electrodes super fast. And then, once you're wearing them, you should also be able to wear them for a prolonged time without having to worry that cables might snap or without having to draw your attention to it so that it continues functioning once applied. So with the first sleeve that we set out to build, we really focused on this question of deployability.
So we took a standard off-the-shelf sports sleeve, cut it open, and lined it with conductive fabric from Statex. We then used snap connectors to connect from the outside of the sleeve to the electrodes on the inside, soldered wires onto each of those snap connectors, and then kind of grouped those wires into veins that then ran up the sleeve. Now, in order to get a good connection between that electrode fabric and your arm, you need to use electrode gel. And this is kind of super sticky gel that makes sure that you kind of get good skin contact. And we knew this from the start, and so that was part of the motivation for cutting the sleeve open. We kind of envisioned this process in which you could lie your arm down along the sleeve and then just kind of zip it up yourself.
So how wearable was the sleeve that we ended up making according to the different framings? Well, it worked. We were able to get people to perform movements that we planned. We collected high-resolution spatial EMG data. We were able to run an experiment with it. From a technological perspective, awesome wearable. From a sensory motor perspective, this thing kind of sucked. It was really uncomfortable. It just wasn't very appealing to wear. And from a social perspective, well, I think the aesthetics are cool. Would you wear this in public? Probably not. And what about deployability, the thing we really wanted to solve? Yes, we were able to use this in the experiment and apply it relatively fast. But we were nowhere near the type of deployability, the type of walk up to the closet, take it out and wear it that we were really interested in. One of the reasons why it was so uncomfortable and hard to wear was that we started with this nice and flexible material, and then we added electrodes, we added cables, we added layers, and in the end it became this very stiff, bulky thing. And that made us realize that we really need to focus more on manufacturing. And that when designing a wearable, we really need to consider wearability from ground up and kind of bake wearability into the design and manufacturing rather than adding it as an afterthought.
So we got together with Rachel to produce another iteration of the sleeve with some kind of much smarter fabrication techniques and with a view to addressing kind of primarily some of the robustness issues of the first sleeve. So this second sleeve went through quite a detailed tailoring process, which we cover in more detail in the paper. But importantly, we moved from sewing as the main kind of fabrication and binding technique to a fabric glue. And in pursuit of replicability, we also moved to a kind of laser cutting fabric pattern process, such that eventually we could get to the point where you'd simply laser cut your fabric, you'd stack everything up with some glue in between, iron, and you'd be done. Importantly here, we made some changes to the electrode layout. We chose not to cover the entire arm in electrodes because you end up covering bones and things which aren't very comfortable when you stimulate them. So instead, we just covered approximate muscle locations with electrodes. And this reduced our overall electrode count from about 60 in the first sleeve down to about 24 in the second sleeve, which also makes everything a bit more manageable. And also we refined the fastening technique here. Drawing inspiration from, for example, corset design, but also from Salomon trail running shoes. You got this kind of string approach where you pull and it fastens everything and then you tie it off.
Anyway, so how do we do? We actually did really well. We were super happy with the manufacturing process, which really supported wearability. But what we managed to do this time is make the sleeve super comfortable. So it was actually really nice wearing this. And from a psychophysical perspective, it just kind of vanished. Though in some kind of extreme movements, the material was stiffer than we had planned, so it did constrain your range of motion a little bit. What about the aesthetics? Well, I personally really, really like the aesthetics. But it does kind of have this medical touch and a somewhat, you'd get noticed wearing this. So if we want something to blend into everyday life more, we'd need to kind of tone down the aesthetics. And what about deployability, which was kind of what we really cared about and invested a lot of thought into? We thought we had fixed this problem of application, but we realized that we created a fastening mechanism that kind of required two hands to fasten it. So in the end, it was really hard to do this alone. If you had a friend helping, super easy, but doing it alone was a problem. So that's something we'll need to address. And prolonged use was because of the well-made construction, this thing just kind of worked and you didn't have to worry about it anymore. One thing we noticed is that there's something really nice about this way of building it because it allows working on different scales. This manufacturing process is something that you or I can do, or a company can do at scale. And that's actually really exciting.
Finally, we have design iteration 3, or slightly more realistically perhaps, design iteration 2.5. Now with the development of this sleeve, we were especially interested in using EMS for typing. So with this sleeve, we added a half glove, which allowed us to support thumb and little finger actuation. And we really refined the manufacturing process such that we can actually now get down to effectively laser cut, stack and glue, and iron rather. And for the new fasteners this time we tried cummerbund buckles and Velcro straps, which actually afforded a fair amount of kind of flexible fastening, but Velcro itself is quite stiff and that starts to constrain the flexibility of the sleeve again a bit. But you'll notice that actually on the glove we have one D-ring on this design, and D-rings are the solution. because you don't need Velcro, you don't have to faff around with anything like that. You can just use the base fabric to pull through the D-ring to fasten, and that works brilliantly.
So, did we fix the remaining problems? We could resolve the biomechanical issues. This one allowed for a greater range of motion. The buckling mechanisms, they allow people to put it on their own, so it's really easy to apply. And the aesthetics are just simpler. So you could conceivably wear this in public possibly without people even noticing. We did realize something interesting because here we focused on a very specialized function. This device is no longer as general purpose. With our previous designs, if we would put it on a very small person or on a bodybuilder or something and the electrodes no longer line up, you could just choose other electrodes. Here, if they don't line up, you're kind of out of luck. So it generalizes to other bodies much less. And this is something general which we think applies to this type of wearable technology where you can perfect it by customizing it to the size of the arm and make it work perfectly for one person, but then the next person probably can't use it. Or you can have a less perfect device which works for a broader range of the population. And you have the same with function. You can specialize in one function, or you can have a general purpose device which does a lot of things but not as perfect. So we started out with kind of these technological, sensory motor, and social focuses of wearability. And what we've discovered through our own work is that the manufacturing process, the ability to deploy, and the potential customization of these devices are something that just really needs to be considered when discussing wearability.